Next part is the network hardware, which is required to communicate uh, your data to the internet. Now there could be different network hardwares you can use. uh, this could be Ethernet, Wi-Fi, Zigbee, or Bluetooth. There could be other hardwares also, which can like cellular hardware, which can also take your data to internet. Now I'll be covering what each and every hardware and how it is communicating in the coming videos, but just to give you an understanding that this network hardware could be inbuilt in the microcontroller, or maybe you need require a shield for it, or you can add up this you can connect this hardware directly to the market microcontroller. So that's this all three things like microcontroller, network, the sensors, and this network together makes your entire device architecture. But the later part comes when you send this data via some communication medium to internet. Now this plays a major role that which communication medium you should use or protocol you should use to send data from your devices to the internet, to your maybe your cloud solutions or to your hosting platforms, and receive that data at the end. So there are various protocols which you can use, like HTTP. MQTT is is messaging queue telemetry transport. CoAP is constrained application protocol. So they have different advantages, disadvantages on that, and they are built on TCP, UDP. They could be IP based, non-IP based. It could be anything. It depends completely on your use case, how you need to communicate uh, to internet, and what type of protocols you need to use. Now uh, you would be sending data across internet, and it could be a huge chunk of data or small chunks of data which is need to be sent. So the protocols play a major role in it, that how each the communication is happening, whether it's a publisher subscriber sort of interface onto it, or maybe it's just a stateless, or maybe it's on a socket connection. Or it could be kind of a web sort of interface, which is like a RESTful protocol or something, RESTful services or something like that. So this protocols has a major importance in that's why this may not be any hardware or maybe a software. There might be some libraries which you need to use in your applications on both sides, but they are very important when you decide to make a complete IoT application. Next part is the server side, or the app wherein you want to host your application is. That is the it could be cloud technologies, or you can host your application in your whole normal hosting server. It could be anything, but it all depends upon the use cases, right? As I mentioned, now most of the corporates are moving out to cloud technologies. The reason because they don't want to maintain the infrastructure required for their applications, and clouds are giving a better solutions now, which is more scalable, maintainable, and you can concentrate on your application rather than infrastructure. So they provide a lot of services like IaaS, that is infrastructure as a service, platform as a service, or software as a service. So all these services they are already providing. You can leverage them or you can create your own. It all depends upon what how you want to deploy your application, or how you want the application to be scalable or not, and all this parameters to be considered. So from from your hardware devices, you're using communication protocols, sending the data to your cloud technologies, or maybe your hosting server, and from there we need an interface to check it out, that what is this actually, what is this data. We need to see that this data, and we need to react on it. So we need some front ends to understand that, and there where the technologies come in picture, like web technologies, The mobile technologies, the native application. Web technologies are websites, web applications which you can host, which you can develop. Mobile technologies are apps which you can create for iOS or maybe Android or Windows. Native applications is the thick client applications which you can create for different operating systems, as mentioned. So this acts like a front face of which, through which you can communicate to this hardware, or communicate to the sensors, and the sensors, they can show up their communication to you or via internet, and that can be done remotely, right? So we are using web technologies and mobile technologies to have a remote, you can say, communication. So same way, you can communicate with your devices that way. So this plays a major role in just showing and kind of communication medium for humans to the devices, that and control over them, right? So that's also one of the things, and the last part is the analytics. Now, data mining and data analysis have become a very major part in current IoT current scenario. The reason why is because this data can be analyzed and understood, and you can put a better algorithm to it, and you can leverage, or you can say you can uh, create certain opportunities out of it. As you can see, Facebook, Google uses our data which is being placed on online, and it provides us certain, you can say, certain advertisements or uh, potential offers, or anything which we are interested in, or maybe news also, and we tend to watch them more, because that is something which we like. And how they have come to know our likes is because they have analyzed our data, our patterns, and that way we can also analyze and understand the patterns of the devices, how they are sending data, where they are placed according to where you have kept the particular device, and how it is reacting to the environment. So this all data, if you can analyze and you can create an opportunity out of it, then it helps a lot to create a business out of it, and you can help your clients, or maybe provide a better solution, or make you can also customize your business solution according to that, and also get better clients because of this all data analysis. Now let's take an example of simple sockets in your house, and each socket is sending some data, like the energy usage of every socket in your house, and you can analyze the data and check out that from which place the more energy is being used up, and why, and how you can reduce that energy usage. Now if that devices are just sending data and you're just switching on and off, it won't make that much sense. But now if you can understand which area is actually taking a lot of energy, or there is a lot of energy usage, uh, you can look into it and you can act upon it. You can also place some uh, scheduling over it, and that way it will benefit a lot to you in cost wise. So this is a very small example which I have taken, that to related to household things. But there could be a bigger market on analysis, and there is a bigger market on analysis on this part, and that's what the IoT applications are for. It's like taking that data, storing that data, and not just storing it, making it an information and knowledge, and using it for analytics, uh, to create some analytics out of it and opportunities out of it. So that's how the entire IoT architecture is placed. There could be in between components also, but I'm just having a bird eye view of the complete IoT architecture, wherein all these things needs to be placed to create a better IoT application, which will be really helpful for your business use case and your clients. So that's with it. So I will be covering more in detail in coming videos to every block in this. If you need some more information about a particular block, just comment me and let me know. So while creating videos, I will take care of it, that I cover that part also. And if you like the video, do share it, subscribe it, and comment on that. Do like our Facebook page and also follow it. We'll be sharing more videos over there, and we'll be letting you know. That would be the best way to let you know the new videos coming in. All right, so take care and see you in the next video. Thank you.